Sometimes we get a question why there is a C value or a 20-hour indication on the battery, and sometimes there isn't. The reason for this is that the rated capacity for some batteries just isn't a fixed value. The capacity is depending on how you use the battery. Especially the traditional lead-acid batteries, such as flooded batteries, but also AGM, gel and carbon models, are based on a chemical principle. This chemical principle is able to convert chemical energy into electrical energy and vice versa when charging. This process works very well, but has some limitations. One of them is that if you discharge a battery with a high current, the battery is not able to convert as much energy compared to what it would be if you would discharge slowly. So how fast is fast and how slow is slow, you might wonder? Well, when discharging a battery on a 20-hour rate or on a 0.05 C, the capacity in this example graph is 100%. So this battery model would be defined in that capacity. If this would be a 100 amp hour battery, the 100 amp hour would be available when the discharge is done in 20 hours. Or in other words, the discharge current is less than 5 amps. If this same battery would be discharged faster, the available capacity would become less, even though you have the same battery. When going extreme and discharge this 100 amp hour battery with a 50 amp current, the available capacity would be all of a sudden only 30%. So it would appear to be a 30 amp hour battery instead of a 100 amp hour. To optimize the lifespan of a lead-acid battery, the advice is to limit both charge and discharge current at about 20% of the capacity. A remark on less capacity due to high discharge current is that the other side is also true. If you would go slower than the 20-hour rate, you have more capacity available than the model indicates. The factor in how much more or less capacity you have available caused by the discharge current is called Peukert factor. This is an important value as you will need this factor also when setting up a battery monitor, for example. The battery monitor needs this value to calculate the actual available capacity. For gel, AGM and flooded batteries, this factor is 1.24. Do all batteries have this effect? No. When looking at the same diagram, but then for a lithium battery, you can see that the 1C value, or 100 amp in a 100 amp model in our example, already results in a capacity slightly higher than the rated amp hour power. Even at a discharge at 3C, so 3 times higher than the capacity, 300 amp in this case, the capacity is still about 90%. So the effect on the capacity due to a discharge current is neglectable. Therefore, at lithium-type batteries, there is no mention of a C rating or 20-hour capacity. The advice for lithium to optimize lifespan is to limit both charge and discharge current at 50% of the capacity. So, when you need to decide what capacity you need for your system, you need to figure out how much energy is needed in total. You can do that by looking at the sum of the current draw per item times the time each specific load is active. But even as important is the height of the discharge current, as it could well be that you need to install more battery capacity to overcome the effect of the Peukert factor. Besides this, also the discharge floor should be decided. You might know that the deeper a lead-acid battery is discharged, the less lifespan it will give. The optimal curve between what you invest and what to expect lifespan-wise is not to go beyond 50%. At lithium, this is a bit more easy. The installed capacity there is what you're able to use, and the optimal maximal discharge floor is at about 15 to 20%.